In this video, I'd be talking about inner classes. There are four kinds of inner classes: regular, method, local, anonymous, and static nested or top level classes. Um, so first, let's talk a little bit about where inner classes are necessary. Um, okay, so say for example, you are implementing a chat client, and then for that, you have a class chat client in which you define your GUI components, and you also need to have an event handling class because this class takes care of event handling on these GUI components. Now, say if you have an instance of chat client C1 and you need to have an instance of event handling E1 tied to C1. So, I mean, you have your functionality in two different classes because the functionality of event handling is different from that of chat client, um, and yet they're related and they need to be bound. Now, it would be considered a better object-oriented design if you had your event handling class within the chat client class, because every instance of chat client needs an instance of event handling, so it's better to make this relationship implicit rather than making it explicit for the programmer to have to do it explicitly. Now, in case of inner classes, uh, the relationship between an instance of E1 and C1 is tight, right? So it's implicit too. Okay, so now E1, which is an instance of event handling class, can have access to any member of the chat client class. Now let's first talk about the first type, which is the regular inner class. Right, so in this example, I have a class myouter and a class miner. So if I do java c myouter.java, it's going to generate myouter.class and $miner.class. You could invoke Java on this, but not on this. So if you could see, I have a private data member that belongs to myouter. Private index is 7, which could be accessed directly in miner. So right, so you can access any member of the outer class. Now, in miner, in inner classes, you cannot have static members, right? And the way you would create an inner class outside myouter class is by saying myouter m is new myouter, and myouter.miner mi is m, which is the outer object you have created, dot new miner. So by doing this, the instance that you're creating, which is the new miner, right, is tightly bound to the outer instance. So that said, you cannot create an instance of an inner class without creating an instance of the outer class. So you need an instance of the outer class to create an instance of the inner class. So you could as well do as a shorthand notation. You could combine these two into one by saying new myouter dot new miner. So in this case, the inner class instance is being tied to the outer class instance, and because of this, well, this might be the reason why you can access any data member of the outer class from the inner class, because the inner class has a reference to the outer class as this. So now if you are within the inner class, this refers to the inner instance, and myouter.this refers to the outer instance, right? So if you could look at this, right, this is where it is. So the inner instance knows about the outer instance. So myouter.this refers to this instance that this one is tied to. Okay, so now let's talk about method local in inner classes. And yeah, just forgot to tell you the sort of modifiers you could apply on the inner class. Is there could be final, abstract, public, private, protected, default, static. But if you apply static to inner class, that will make the inner class a static nested class, which is a different type of inner class, or strict FP, right? And one more thing is that, okay, if you were to do, you could do this within the myouter class, and this works because even though it seems as if there's no my outer instance to tie the inner instance to, but what should be noticed here is that there is an implicit this, right? So it's just like saying, you know, having, oops, having this dot new minor, so you're tying minor to the current instance of my outer. That's it. Now let's talk about method local inner classes. Well, these are the inner classes which could be declared within a method, right? And the method could be an instance method, or it could be a static method. Um, so let's see what you can. So okay, here is the class. If you you can have a if you have an inner class within the method, you cannot access the local variables of the method, so L cannot be accessed. However, the final local variables declared within the method could be accessed, right? And because this class is declared within an instance method, you can access the private instance members, as well as the public static members. Oh, sorry, the private static members. But if you were to have the same class within a static method, you can only access the static methods, but not the private instance methods or members. And these two are the same. You cannot access the local members whatsoever, but you can access the final. And right, and then the way you would create an instance of my_inner is you would create an instance after the declaration of minor, but within the method. So within this, but after the declaration, right? The reason why you cannot access local variables is because, say for example, if I were to pass this instance to another method, say, if I have another method right here, and if I try passing this one here, now m would be passed to that method, and this method would hold an instance of m, or this object here. um, but what should be realized here is that the local variables would be removed off the stack after or by the end of this method here. So if now this method, which is holding on to this instance, tries to access L, it doesn't make any sense because L is not on the stack anymore. But F, which is a final variable, is allocated a different memory. It's not on the stack certainly, so that's the reason why you can access F but not L, right? Now let's talk about anonymous inner classes, the third type. Consider we have a class popcorn with this method pop. Now if I do something like this, popcorn p is new popcorn, and have the method redefined, it's just like saying class anonymous extends popcorn, and you override pop method, and you create an instance of the new anonymous class, and then you assign it to the popcorn's reference p. So this is essentially these two combined, but this is like a shorthand notation, this one. Now say if popcorn was final, if it was a final class, you certainly cannot do that because you cannot extend popcorn, as popcorn is a final class. And one more thing is, say if you were to create your own methods, say my own, it's just like saying you have a my own method within anonymous class. There's no way you can access my own method using using popcorn's reference p, because when you do this, the compiler goes and sees, well, let me see if I have my own in popcorn. Well, it doesn't, so it throws an exception, or sorry, an error, right? So that's one flavor of anonymous inner classes, in which you can subclass an existing class. The second flavor would be to implement interfaces, which is exactly the same. The limitations are, in flavor one, are you can extend a class but not implement an interface at the same time. In the second flavor, which is when you implement interfaces, you can only implement one interface but not more than one. The third flavor of anonymous inner classes is argument-defined anonymous inner classes, in which you would implement interfaces within a method argument. And it's exactly the same. It's just the place where you implement your interface. So as you can see here, bar has a method do which accepts an argument of type foo. Now you're writing your own class. Now instead of implementing another class which extends foo and use that instance here, you're directly over or implementing foo here. So this instance would be passed to this one. So you implement as well as create the instance and you pass it to this one, so which works fine. Now let's talk about the final type, which is the static nested classes. These are, I mean, um, I mean, at the face of it, it seems as if this is just like a regular inner class, except that you have a static keyword preceding the class declaration. However, you don't. I mean, the inner classes don't share any tight relation between the outer class. I mean, sorry, the inner classes don't really share a tight relation with the outer class. It's not that you need an instance of the outer class to create an instance of the inner class. You don't have any such constraint, because the reason why you have static nested classes is only to give it a scope. So whenever you're trying to create an instance of miner from outside myouter, you would have to do myouter.miner is new myouter.miner. So if you notice, you're not creating an instance of myouter to be able to create an instance of miner, just like in regular classes, um, right? So you cannot access non-static instances of outer classes within the inner class, within the static inner class, because there's no this reference of outer class within the static inner class. So the static inner class can only access the static members of my outer class, right? And you could also do this, like you could treat static minor class within my outer class as just like a type. You could do minor, m is new minor. That's the end of it. Thank you.